Hi everyone, welcome to the webinar. We will be waiting another 2 minutes before we start so that people have time to join. Feel free to use the chat box to introduce yourself. Please note that the participants will be muted the whole time, so only the speakers and the panelists will have opportunity to speak out loud. So use the chat feature to communicate between each other. Hello everyone, it's 9:02 in Washington DC. I think we have over 80 participants online and we can start today's session. My name is Zuzana Dobrotkova. I am a senior energy specialist at the World Bank and I will be your moderator today. Before we start, a few pieces of information. Please use the chat box to introduce yourself and chat between yourselves. Please use the Q&A box during the session to ask questions to our panelists. We will answer those both in written as well as during the Q&A session towards the end. We are recording this session and it will be posted online in a few days. And we will also share the PowerPoint from this session. The webinar is organized by the Energy Storage Partnership, which was convened by the World Bank to foster international collaboration to adapt and develop energy storage technologies for developing countries. The partnership has now over 30 different organizations as partners, and it has been active since May 2019. The paper that we are going to present today is a collaborative effort of several partners from the Energy Storage Partnership, and it will be available online in a few days. The paper that we will present today is namely collaboration of the World Bank, the International Energy Agency, the International Council on Large Electric Systems, the China Energy Storage Alliance, the European Association for Storage of Energy, the US National Renewable Energy Lab, and the South Africa Energy Storage Association. Now, let me introduce our panel today. So our main presenter will be Simon Müller. Simon Müller has been independent consultant to the World Bank for this effort. Simon, on top of consulting, currently works for a renewable energy utility in Germany, where he's mostly focused on green hydrogen and sector coupling. But you may remember Simon from his previous role as the head of VRE Grid Integration Program at the IEA, where he has established this program and was running it for many years. I have personally known Simon for the last decade. We've been working together in our respective roles, both at the IEA initially, but continued collaborations as we moved on to different roles. So he will present the main presentation. And once Simon is done, then we will open it to the panel. Our panelists today are Brittany Alzarey from the European Association for Storage of Energy, then Mikhail Nikomarov from the South Africa Energy Storage Association, and George Dudley from the China Energy Storage Alliance. They will give us their perspective from their respective regions on how energy storage policy and regulation has been evolving in their countries and sub-regions. Now let's get started. Simon, the floor is yours.
So thank you very much, Susanna. I was just getting the screen sharing up and ready. I hope everybody can see the screen now and can hear me well. If that's the case, let's get started. A warm welcome also from my side. Good morning, good afternoon, and good evening to all the attendees that we have at this webinar today. I will spend the following 15 minutes or so presenting some of the main findings and key messages of the report. And I'll do this with a set of slides that I'll be showing to you simultaneously. I won't go into this too much. Susanna has already introduced this. It's been a collaborative effort as part of the World Bank Energy Storage Partnership. And what the report provides is guidance on the one hand, determining the value of storage from a system perspective and how policy can help to align that with the perspective of investors, because ultimately that's one of the big challenges or one of the big tasks of market design, of regulatory structures, that the two can be aligned. And how you can do that and how you can facilitate that is part of this report. Now, first of all, why is it timely and why is it relevant? Not only to look at energy storage, but also to look at policy and regulation in this context. First of all, we know, and I'll say a little bit more about this on the following slide, that we need increased flexibility in power systems in order to reliably and cost-effectively integrate increasingly cheap or low-cost wind and solar power. Hand in hand with the need for flexibility, we see deployment of storage, in particular batteries, growing rapidly. And if you look at long-term scenarios, irrespective of which organization you consider, they see a growing and important role for storage technologies, including batteries. Storage can make a substantial contribution towards cleaner and more resilient power systems, and this is particularly the case in developing countries that often lack flexibility in their system, that are characterized by so-called weak grids with low reliability and often polluting a smaller scale generation that runs, for example, on heavy fuel oil. And having a package of renewable energy and storage can be a good way of substituting these resources. And then, of course, if you look at it from a regulatory perspective, storage is new to the power system in many cases. I mean, especially batteries. We've had pumped hydro for a number of decades, but also there, regulatory-wise, it was not so significant that you had clear structures for it in all cases. But now it's very, very clear that we need comprehensive frameworks that really treat storage as a resource of its own and not try to put it into a box where it doesn't really fit. But of course, this is a challenge, and that's where guidance is needed. And it's not just about this particular consideration of how you characterize it as a resource. It's also about what remuneration mechanisms are in place. How do you make sure that investments actually go ahead and that projects can be implemented? Now, I'll come to the need for flexibility. If we look at growing shares of variable renewable energy, so VRE, that's wind and solar power primarily, and take the perspective of the power system, we see that actually challenges evolve in phases. When this happens precisely, so at which share of wind and solar generation differs from system to system, but all systems undergo a sequence of phases. The first three basically go from, if you have a very large power system and you introduce the first wind and solar projects, these are hardly noticeable. At some point, you will see minor to moderate impact on the grid, so that system operators might have to run some assets differently, but all in all, the system can still cope. That's the second phase. In a third phase, VRE determines the pattern of generation also for the non-VRE resources, so that flexibility really becomes the key property of the system. And then as we go to higher phases, at some point the stability of the system becomes relevant. That basically means how does the system respond on the very short term to specific disturbances. And then as you go further, it's also making economic use of possible surpluses. So when you really have very high shares, close to 60–70% in electricity, where you then think about how can I use this to also decarbonize other sectors, and how can I make sure that I really don't need other resources to meet demand, even when the sun doesn't shine, the wind doesn't blow. Now, this categorization was developed with large power systems in mind. Now, if we look at developing countries, it can easily be that by adding the first project, if it's fairly significant compared to the size of the power system itself, basically the system skips the first three phases and goes directly to phase 4, and where you see stability issues and so forth. And it's in those advanced phases where there's an important role for storage. If you look at what the key transition challenges are from one phase to the next, I'll go immediately to this middle one to ensure robust power supply during periods of high VRE generation, and also absorbing when you would otherwise have a surplus. And precisely in developing countries, these phases become relevant sooner, and it's here where storage plays a very important role. However, as you can see on the right-hand side from the list of flexibility options, storage is just one of the resources that is capable to solve flexibility issues, and of course it's important to always consider it vis-a-vis some of the other options. Now, when we look at energy storage itself, it's very important to keep in mind that we actually have a heterogeneous set of technologies, a very different types of technologies that are also suited to different applications. I mean, I expect that most of you know a chart like this, or in different variations. In this case, you see the size of the storage and the storage duration, and on the right-hand side, the different applications that result from this. And the main message that we want to pass here is that we cannot discuss the role of storage if we don't specify what the use case is. So what type of system challenge storage actually addresses. And different storage technologies are suited differently depending on the use case. Now, what is a use case? Since it's a very important concept in this context, just to recap. So it's defined as a specific power system need, which occurs frequently and in most system contexts, and which is significant enough to justify the deployment of a technology solution tailored to meet it. Now, a very common example from AC power systems is frequency control services that make sure that the frequency stays within a certain nominal band and we have reliable electricity supply. A use case, even if we say frequency control, for example, it does not imply a specific technology solution. So it means that energy storage might be best suited to provide it, but it may not. If we pick up the example of frequency control, as Susanna mentioned in the introduction, that I also work for a German renewables company. The company, for example, operates a large battery that provides 22 megawatts of primary reserve, simply because it's a cost-effective solution for providing this service, even in an integrated power system such as in Europe. So specific use cases can mean that storage is the most cost-effective option. And of course, as costs come down and integration challenges grow, we see more and more use cases where storage has an important role. If we then zoom in onto which types of use cases there are, I don't want to go through this table in detail. You'll see in the report a list that explains all of these different use cases, but I'd rather like to draw your attention to basically the larger blocks here. You see a top one that is not shaded, or that is white, and here you see the timescales running from very short-term, sub-seconds, to quite long-term, months to years, and to look at what is actually the important characteristic of the storage technology. So for example, if you want to be very quick, of course, the storage needs to be able to respond even within milliseconds, and that has implications for which the technology is best suited. And then if we look at the other extreme on long-term energy storage, it's very clear that we need a decoupling of energy volume and capacity to store bulk quantities of energy over a longer period of time. The other point that I'd like to make is that if we look at the use cases, we have broadly categorized them. This is not a very sharp categorization. In some cases, you can argue where does it belong, but still, I think as a first order approach, this is valid. You can have use cases that have currently been met by generation, or that are met on the customer side, or where it behaves more like a load. And then it can also substitute a network asset. And this immediately highlights the challenges that policymakers and regulators face, is because storage can act as many different resources depending on its use case. It is important that it is actually defined in its own right, and then that regulation does accurately consider the different use cases that it can be used for. You'll also find something in the report that goes one step further than the use case that many of you will know, and actually introduces a concept that I think is very, very useful, which essentially, if we take general system needs in an AC power system, we can derive a set of general use cases, and that's what I just showed to you. However, we have specific needs in a given power system. So for example, while frequency control, of course, is a very general aspect, it will depend on the exact characteristics of the power system, how you differentiate this into different classes of reserves, how fast they need to respond, how long they need to stay online. It also depends on what is the policy, market, and regulatory framework that is in place. And here, the notion of market, we really mean in its broadest sense. We're not talking about liberalized power markets here necessarily, but really, what's the overall governance framework? And if you take these two together, you actually have the components that drive the business case for storage, and that defines the concrete application case. And it's this case that then leads to specific projects. The main message here is, when you look at it from a policy perspective, you need to think about, okay, what's the use case that I want to serve? And then when you combine it with the regulatory framework, that's actually what results in something that will be picked up by the private sector or by whoever develops the project. Now, policymakers will often be faced in a situation where maybe somebody with a particular interest of selling one technology solution will come to them and say, well, actually, you should, I don't know, put in a lot of storage here or do this. And it can be quite difficult to see, well, is it actually best from a system perspective? And the report explains how it is possible to determine what actually is the economic system value of storage. So this defines the net benefit for the entire power system, looking at the all-in costs of building and operating the power system. So the factors to consider here are the CapEx and OpEx that can be saved, possibly the increased reliability of the system, and reduced load shedding. In order to calculate the system value, you need a tool that is able to model the power system accurately, and where you can compare different scenarios, one scenario without storage and one with storage, and you can see, well, what's the net cost difference. So this is assessing the system value. When you do this, you can adjust the model to look at different use cases for storage and identify which use case is actually most relevant from a system perspective. Then before going into saying, okay, possibly we have to pay a lot to developers, or we have to spend a lot of money from our regulated utility to build these projects, it's very important to check what are the non-economic barriers that are in place. Because often administrative hassle, project delays, risks, you can buy yourself out of them, but it's a very poor way of spending money, because by reducing the non-economic barriers themselves, projects can go ahead more smoothly, more quickly, and at a lower overall cost. And then in the next step, once one has checked what economic barriers are there, it is about setting up remuneration structures for this use case that actually provide a revenue stream that is capable of getting ahead investments. So this is the component of financial project value. And essentially the objective of good governance frameworks, of policy, market, and regulatory frameworks is that the two are well aligned. Now, let's say we've done this analysis, we have identified use cases, and now the question is, how can I actually provide remuneration to a certain project? And we've thought quite a bit about how we present this in the report, because often there is this binary distinction where people say, well, I have a vertically integrated regulated system, and then I have a liberalized power market. So essentially in the vertically integrated case where you have the generation, transmission, distribution, and retail of electricity all in one hand as a regulated monopoly, and then in the full-fledged unbundled version, you would have a competitive wholesale market where generators and large customers interact, and then you have retailers that supply smaller customers, and then of course you have an independent system operator for the transmission system, possibly even independent owner, and the same for the distribution grid. This type of characterization does not fit well to capture the different use cases and the different remuneration structures that apply for storage. I'll give you an example. In the European case, we do have what one can generally consider a liberalized wholesale market, so a liberalized design. However, the frequency control services are procured by system operators where they act as single buyers. So even within a liberalized setup, we have sub-markets which work differently. And this is exactly what this categorization is about. We can have a non-market setup where, for example, a vertically integrated entity simply is allowed to build an asset and recover the cost via regulated tariffs, and this can apply for storage. There can be a single buyer setup where a system operator, a supplier of electricity, or even a vertically integrated entity that has participation from IPPs could also act as a single buyer to procure storage and associated services. But we could also have a setup where we have a full market where multiple providers of storage compete with multiple possible buyers of services on an open contracting market. Often the third case is facilitated by clearing houses and exchanges. For simplicity, they're not on this figure, but of course very important in practice. So these are the three types that can be implemented in general. And the main message here is these can be combined even within the same structure for the power sector. Of course, there's limits to that, and you'll see in the report which use case can be combined with which remuneration model. Now, if we look at the setup of a PPA, that's, for example, in a single buyer setup where you would procure a storage project, but you could even imagine this by a private entity procuring storage. There's many levers that you can use to actually signal the system value that storage provides, also from an investor perspective. What you see here is a multiplier from a PPA, so a power purchase agreement, that adjusts how much the generator receives depending on when they generate. And now let's assume for a moment we have a solar project and we combine it with a battery. You see in the middle of the day, it is not so attractive to inject electricity into the grid. If you can produce it very, very cost effectively, it might still be interesting. But actually, you'll have an incentive to store some of that electricity and release it during the evening hours, possibly or most likely when the system has, or hopefully when the system has its peak demand. And of course, there can be a seasonal component to this, so you get a different remuneration structure by season. So this is one of the examples how you can design procurement mechanisms also to reflect the system value that storage brings in the regulatory structure. And then I already mentioned non-economic barriers as a priority. What are those? So first of all, definition and standards. Is actually storage clearly defined? Are particular standards in place that give certainty to project developers what's possible? The other is permitting, commissioning, and grid codes. So to whom do you actually need to go in order to get permits? Does the grid code, so the technical standard that you need to comply with if you want to connect or when you want to connect to the grid, is it actually suitable for storage projects? And here it's also important, despite the fact that often it will be new for system operators, to not impose unduly high restrictions. And finally, the whole question of taxes, surcharges, and levies. There's often discussion because storage can be simultaneously a load and a generator, that there could be problems of double taxation, for example, paying it once for consuming the electricity and then a second time for releasing it. Removing this is also quite relevant. If we look at the role of stakeholders in a broader way, in energy ministries, I think it's crucial, or we found that it's crucial to articulate an overall strategy for energy storage within a country's broader energy strategy and to define policy goals. This shouldn't be underestimated because this is really what gives a guidance for a sector to see whether it's worthwhile to develop a pipeline of projects and really be present and active in a specific country. Then on the side of regulators, it's really about being proactive in updating regulations. Often maybe regulators will already see, this doesn't really fit. And here it's important to maybe also make proposals on how this could be changed so that there's a fair remuneration of services that storage can offer. From a planning perspective, this is about really assessing the different use cases, making sure that also the planning models are there, that they're up to date. State-of-the-art models allow better and better modeling of storage, while older models are quite poor at this. So here, this is quite crucial. System operators should also not impose undue restrictions on new technologies. Of course, their responsibility, and that's good that way, is security of supply. But having the right trade-off here really is important. Permitting, I already mentioned this, should go more towards a one-stop shop approach, so that you know from where to get the permits, and often to have one that focuses all the ones that are needed. And when we look at the manufacturing side, I think this is also very important, also commitment from the industry to see that in developing countries, product specifications actually need to match the demands there and the characteristics, including the types of maintenance contracts, warranty agreements, are in line with system needs. So to summarize and conclude, energy storage is growing rapidly and can make a substantial contribution towards a cleaner and more resilient power system, by, on the one hand, facilitating uptake of variable renewables, but supporting also reliability and energy access in developing countries in particular. Establishing an enabling framework for storage is really about understanding costs and system benefits of energy storage, and having the infrastructure in place to do that is really crucial to make informed policy decisions. We do want to highlight that energy storage is usually not the only option to meet power system needs. We see clear trends why it is increasingly, for more and more applications, the best option. But from a country perspective, it's best to really benchmark it across different alternatives. And then when it comes to remuneration systems, they should be robust in terms of providing sufficient certainty and accurately reflect the value that brings that storage brings to the system. We show these three basic remuneration models that are possible depending on the system context, and something that can't be stressed often enough, even though if it can be quite tedious, is that the removal of non-economic barriers is also a very important priority. Okay, this is my input for now. Sorry to have taken a little bit longer, but I hope it was useful. And now back to Susanna.
Thank you so much, Simon. I would repeat to everyone that the presentation will be shared after the webinar, as well as recording. So you will receive all of these. At the very last slide that Simon didn't show, there is actually an email address to SMAP as well as to me. So if you have any questions, feel free to send them also later. Simon is going back to it. Yeah, there is an email address for SMAP and for myself, and I can direct then the questions also to the appropriate partners if needed. Feel free to ask your questions also now through the Q&A box, of course. We are looking forward to them. I have already answered a few. The report itself will be available in 1 or 2 weeks. We need to finalize some little final tweaks, and thanks for the comment about thermal storage, which indeed is omitted in that slide. But we actually have an interesting box in the report that showcases some analysis that we have done for Jordan, where we were thinking about whether thermal storage or batteries are better option for their power system. So now let me go back to my panelists and maybe to Brittany first. As Simon has mentioned, one of the first barriers that countries usually see is that there is a lack of clear definitions and kind of status of storage as an asset in the power system. So what do you see as experiences from Europe? How did countries tackle this? And was there some common approach or everyone on their own? And what did you see in that market?
Hey, Susanna, thanks for the question, and thanks for giving me the chance to share some experiences from the EU regulatory policy discussions. So what we saw in Europe was that there was a lack of a common approach. So a lot of the energy policy is defined at the EU level and then implemented across the now 27 EU member states. In the 2009 energy package, there was actually no definition or mention of energy storage at all. And that was a really big problem for the storage sector because it was really unclear how storage fits into the system. Last year, we finalized the first, the new package of energy legislation, the Clean Energy Package, which for the first time had a definition for energy storage. This is really the first step in integrating energy storage in the legislative framework. So what we found important at EU level and something that EE's advocated for many years is to have a definition that's technology neutral. So also recognizing power to X technology, so power to heat and power to gas as energy storage that allows all of the different storage solutions to compete on a level playing field. So that was implemented in the recast electricity directive. And it's a good first step. Now it needs to be implemented across all 27 EU member states in their national legislation. So that's ongoing at the moment. The broader issue still is that energy storage doesn't really fit neatly into any of the existing categories around which the energy policy is designed. So we see a couple of concrete problems. Double taxation of energy storage, this is something that Simon mentioned already. So if energy storage is not really clearly defined, it can be classed sometimes as a generator and sometimes as a consumer and then taxed twice because of this. So that's a really big problem, and that's still an issue in the EU. Some EU member states have started to address it, but there has been no EU-wide approach. But we're happy to see that last week the European Commission announced that this issue would be addressed as part of the review of the Energy Taxation Directive. So that's something that should be addressed and solved within the next 2 years at EU level. And then another issue related to the lack of a clear asset class for energy storage was the ownership of energy storage. I'm not going to go into that because it's quite complicated, but there's a good text box on this in the paper, which gives some examples of how this barrier was addressed at EU level. So short answer, a lot of these discussions are still ongoing in the EU. There's now starting to be an EU-wide approach on defining energy storage and making sure that there's really a clear framework for how energy storage is addressed. There's no clarity yet, kind of in an overall sense, about having a separate asset class for energy storage, but we're definitely moving into the direction of energy storage having a clear role in the system and all of the legislation and policy formally recognizing that. So a lot of work still to be done, but it's definitely, starting.
Thank you so much, Brittany. Let me turn to Mikhail, who is representing here South Africa, but we would be interested also to hear about Southern Africa in general, if you have any examples. So as Simon pointed out, the storage can be used in a wide range of applications known as use cases. And I know that South Africa has done a lot of thinking about this. There is a World Bank project that is supporting Eskom in bringing energy storage into the system, supporting grid integration of renewables in a system that is very inflexible coal-based. Are there any main regulatory barriers that you would want to mention, and how these were overcome, if they were overcome at this stage, and how are things going in general in South Africa, given that there is this really big ambition for deployment of energy storage?
Thank you. Thank you very much for that, Susanna. So, kind of I'll kind of share our thinking about South Africa and some of the thinking that's going on within the South Africa Energy Storage Association, which I chair. So yeah, absolutely. So South Africa has actually had quite a bit of a history working with storage. There's almost 3 gigawatts of pumped hydro on the grid, and as someone has already mentioned before, I think that has kind of fueled a lot of the expertise in the market, and also on the regulatory side. What we have seen with CSP, solar generating technology, a lot of thermal has also been added to the kind of as co-located storage. But really, there are challenges with both of those technologies in terms of there are some use cases that they can't really support, especially if you think about a transmission system or a distribution system. And I think there's a lot of opportunities for storage in South Africa, but also in other countries, whether they're in SADC or elsewhere on the continent. The nature of power systems in Africa is they're very radial. You have these massive gaps that are covered by transmission between where a load center might be and actually where the generation happens. And this is only going to be increased as we have more and more renewables, because those tend to be put into places of great wind and great solar, which is not necessarily where people live. So you have these long lines, kind of like fishbone structure. And you also have the same issues going on the distribution sides. You may have very long distribution networks that have not really been built up, even as demand has grown, in part due to electrification, but in part because just as consumers become wealthier, they consume more electricity. So all of these lend themselves to really good use cases for storage that is embedded into the distribution network, maybe something co-located with substations or in the transmission network. And I think we're seeing a lot more understanding of how you can do some of the things around frequency support with a storage system that also not just defers, transmission and distribution, but also might provide some time shifting in those areas as well. From a regulatory point of view, most of the key things have been mentioned. We had challenges of how you define storage. As a generation, as a transmission, is it its own? And then the push has been very much to call it its own, in a similar way that maybe demand side management is something that a network will treat as a different type of system optimization. Storage can be thought of as something distinct from generation, transmission, distribution, et cetera. Other parts have been around how do you monetize what storage can provide, and I think that has been talked to. Another challenge was around sector planning, and I think this is where we've had some success in South Africa. We've got what's called an integrated resource plan that outlines the generation mix for the country, but it tries to optimize not only generation but also transmission and some aspects of distribution altogether. And for the first time in 2019, that had a dedicated allocation for storage. It's technology agnostic, but I think that was a major move forward in thinking of how does this new tech support the development of the power system. There are still some gaps there. Modeling was mentioned. It doesn't quite capture in all of the locational benefits that some types of storage may create. So there's still kind of opportunities for improvement. And then maybe one last regulatory aspect that I would mention that maybe sometimes isn't really seen or as much is, the government doesn't necessarily only think about the power system. When they think about technology selection or some decision making, they also look at other factors. So in South Africa, these factors are employment, their GDP growth. They could be national security in terms of energy policy. And this immediately throws a kind of a more complicated decision-making structure outside of, well, what's just the lowest cost system that we can have? And there's a lot of arguments that might say, well, we don't want to necessarily have the cheapest system. We might want to have one that is most in tune with the challenges that are uniquely, South African or Namibian or Angolan. And it's not clear what is better. Do we just want the cheapest, or do we actually want something that maximizes employment, or maybe maximizes GDP growth, or maybe incentivizes certain types of industries rather than energy intensive industries, which would obviously benefit from cheaper electricity. So these are the kind of conversations that are still ongoing, and there's a lot of fact bases that are needed to make those decisions, and even getting those fact bases isn't that easy.
Thank you, Mikhail. Very interesting, and it it kind of reminds me of the approach that Morocco has taken around thermal storage and CSP plants, and how much of a consideration there was around industrialization and supporting also local businesses and local jobs. And I think it's something, also now with the pandemics, countries are thinking so much more about that, how to try to be a little bit more self-sufficient. And so it's something that we see also in our World Bank dialogue with many countries, that they're starting to be interested. Thanks so much. Now let's ask George about China. So China, of course, has deployed quite a bit of storage technology by now. What do you see? What were kind of the methods how the Chinese government and private sector brought storage into the system? And if you could touch also on planning, that I think Mikhail made an interesting point, how that helped in South Africa. So I think that would be very interesting also to hear for China. And in general, what are the first lessons from China that has deployed quite a bit of capacity?
Yeah, okay. Thank you, Susanna. So for China, it has indeed deployed quite a bit of energy storage, and for such a actually high capacity amount of storage that it's deployed, China still suffers from a lot of regulatory and market-based issues. I think we can look in terms of planning and how things have been really distributed through China. We could look kind of nationally and regionally. So China obviously is a very big country. So a lot of the ways we see storage deployed across China really depends on the certain needs or circumstances of that region. So for example, we see a lot of the storage paired with renewables throughout the north and northeast, northwest of China, where a lot of the wind power and solar power is concentrated. Towards the east in, for example, Jiangsu province in particular, is a very industrialized area or province, and there's quite a lot of the INC type behind the meter storage there. So talking more, going back to planning, if we look at kind of nationally first, I think that a lot of the policies that have come out from the main regulatory government agencies like the National Energy Administration or the National Development and Reform Commission, a lot of the policies that we see for planning of storage in China has really been more guiding policies, sort of suggesting ways that energy storage should grow or could grow, but not a lot of concrete action in terms of integrating storage into the power grid. We are going to have at the end of this year China's 14th five-year plan come out. So China has their 5-year plan that they make released every 5 years, which lays out for the next 5 years what the economic and development goals are going to be. We're expecting that energy storage is going to be a part of that in the energy portion of the 5-year plan. But it sort of remains to be seen to what extent that's going to be a part of the plan and what kind of concrete actions are going to be taken for that. Regionally, things are quite different, and things often move quite quickly in China. So we've seen, as I mentioned, the renewables in regions across the north of China. And recently, actually, just in the beginning of this year and in 2019, that's sort of become an area that's seen kind of the future or one of the future paths for energy storage in China. So we've had just in the past year or so in Inner Mongolia, Hunan, Zhejiang, a few other regions, we've seen policies come out calling for more storage plus renewables or storage paired with solar, for example. Qinghai province as well, out in the west, where there's a lot of solar, has also in the past year released a shared energy storage model, which kind of helps free up storage that's paired with centralized solar plants and allows them to be dispatched more freely. So there's a lot of kind of innovative things going on. Another area, as an example, is in 2018, we saw grid-side storage become kind of a hot new trend. We saw a lot of new grid-side storage capacity, a couple large projects released, mainly for grid stability. But again, as I mentioned, there's still quite a few problems. So for example, going back to the storage paired with renewables, the sort of market mechanism isn't there yet to make this a long-term application that is going to be able to support storage in a commercial market. For grid-side storage, it kind of came and went it went as quickly as it came. So we saw it come out in 2018, and then policy changes came out in 2019 that I won't go into too much detail, but essentially the grid was investing in these grid-side energy storage projects, and policies were changed to prevent that from happening. So what really the crux of the problem was that kind of going back to what Simon said, is there's no clear remuneration for that type of application. So it's sort of at a standstill until that sort of market mechanism or policy mechanism can come out and kind of fix that issue. So these are just two examples of many different applications and areas, but they can hopefully kind of illustrate how China is kind of at this interesting point where it has a very well-developed industry, a very good value chain. There's a lot of great companies coming out of China, a lot of solutions and high-tech technologies for energy storage, but there's conflict with trying to develop a full market mechanism and trying to get the policies there that are going to be able to support this. So to kind of sum up, if there was one lesson that I would say, it's that, you know, as enthusiastic or as strong as the actual industry can be, it can't really go anywhere, or I guess it can only go so far if there's not that proper policy support there and market support there. Another thing I would say, which maybe isn't a lesson, but could be a lesson down the road, is I think China is a very interesting country to watch for a lot of these changes, because again, there's a lot of energy storage capacity, strong value chain, and as soon as these sorts of policy changes happen, a lot of things can happen on the ground, and it can be an interesting place to see what sort of techniques or what sort of strategies work to actually support energy storage. So I think China is quite interesting in that way, and there could be more to learn from in the future.
Thanks, George. Very interesting. And of course, the first lesson, as always, is policy reversal very bad for the market. And it's interesting to see that even in China, the hybridization of renewables plus storage is kind of, you know, the first use case that proliferates. I guess also because you can just do, you know, kind of go around regulation by having a long-term PPA, and that guarantees you some value stream. And on the other hand, I mean, it's also a little bit crazy that you know, the market is growing this rapidly, and yet even the more advanced countries haven't figured out what is it that that we are actually regulating. Yeah. So I think, you know, it's interesting to watch the different markets and see different issues. And of course, you know, I find that the value of storage is maybe the most that storage is maybe the most valuable in small systems, in very weak systems, because it can bring so many different benefits to the grids, and those, of course, you know, oftentimes really lack regulations even about simpler things. So that's why we wanted to have this paper written and have the conversation that also relates to developing countries. Because they don't have to necessarily go the complicated way, like, you know, California way, but yeah, things need to be done so that storage can happen. Let me go now to the Q&A box, and I see we have received quite a bit of questions. Let me ask Simon first, and then I will go to the other panelists. Simon, there's a question for you. Are you aware of any examples of storage as a full market application?
Yeah, thanks a lot. Actually, it's also connected to some of the other questions. If you look at behind the meter storage, so in the German case, for example, these are small battery systems that customers can use to optimize their overall energy costs, including taxes and surcharges. I would consider those as operating under a fully market-based approach, because you have individual customers that can choose from a variety of different providers that offer to install such a system. So this is actually, it's different from what we have in mind in terms of the power market, the way we commonly think about it, but that's a full market-based way of remunerating storage. Now, if the remuneration is in line with system value in this particular case, that's a different question. In many cases, you have a hybrid approach. So if you look at the Hornsdale battery, for example, part of it, that's the big one in Australia, part of it goes into the auxiliary services market. It's called FCAS market in Australia. And part of it is doing arbitrage on the wholesale market. So in every case where you have a storage system doing arbitrage on a liberalized wholesale market, that's a case of a full market implementation. Now, will that by itself be sufficient to attract investment? You would only see this in markets that show very large spreads that actually make it worthwhile. And then usually these markets are quite shallow. So that means that once you add assets to it, actually the differential disappears. And also there are many factors that can influence it. So you don't really have certainty that these high differentials will remain. So the question is yes, but they're in different circumstances than one might think when you look at the broader or the larger power markets. And maybe one last comment on that. There was also a question on embedded storage. So if this also is about behind the meter generation, right, or storage, it leads to the whole issue of distributed energy resources and the need to have retail electricity tariffs which are well defined and reflect system value, right? I know this is a difficult task, but the more we have distributed energy resources, the package between solar and PV, the more this will become very, very important. Because if tariffs are artificially too high for some customer groups, often via cross subsidies, they are the ones that are going to exit the system first. So this is really an area that's also important from a policymaking perspective, including in sub-Saharan African countries.
Thanks, Simon. I am trying to go through the questions, but I think many of them are kind of touching on how do you stack the values, right? And of course, you know, if you're defined as generator, then you cannot be stacking values that are more related to the grid. Does any one of you, Brittany, George, and Michael, have any examples of countries or, you know, particular markets that manage to do this quite well, or we are not there yet?
At least in Europe, I think in most markets we're not there yet. There are still some markets that are for the first time actually starting to tender services on the market and allow storage to compete. So in many European markets, we're just not there yet. I would also say, aside from value stacking, which a lot of the questions have addressed, one big issue that we see is having some long-term stable revenue streams. And what we've seen in Europe with the clean energy package is it's trying to open up the markets, allow storage to compete and provide more different services, have access to different revenue streams. But at the same time, EU policymakers have reduced the amount of services where you can have a long-term contract. So that really exposes storage providers to a lot of risk. And it's not really, in the short term, it creates a lot of problems to have a strong business case for storage. So that's one point that I would just like to raise, and a lesson learned from Europe, that it's okay if the decision is taken to limit TSOs and DSOs from owning and operating storage, some kind of long-term revenue stream and some kind of support and ability to stack different revenues if needed, because otherwise it's going to be very, very difficult to have a real strong business case.
Thank you, Brittany. Mikhail?
Yeah, I would just add, I think that behind the meter customers that are grid connected have been actually doing a pretty good job of looking at multiple values. I think in front of the meter, it hasn't really been working in terms of multiple use cases certainly in Southern Africa. But behind the meter, yes. So a customer will look at how do I save money either through a reduced demand charge or the time of use arbitrage. But at the same time, they may have power quality issues due to the local distribution network. So the battery or the inverter can help clean up. And then some customers at the same time will install some solar, and then they can also use the battery to help integrate that and balance some of the variability there. And there could even be other factors they might be looking at in their own internal distribution network if it's a large enough customer. So there's been some value stacking behind the meter, but not much in front of the meter.
I'll just chime in and say that no, China is in the same boat. There's not a lot of value stacking going on, and that's one of the main challenges too, is to diversify out of one particular use for energy storage. Even Mikhail just mentioned behind the meter. Actually, in China, the residential behind the meter doesn't really exist because the cost of residential energy here is quite cheap. So it's mainly those arbitrage uses for large commercial buildings or factories, industrial usages. Yeah.
Thanks, George. Simon, maybe you wanted to comment on the kind of European versus less developed countries differences?
Yes, absolutely. I think a general issue when it comes to flexible resources, and storage is no exception here, is that essentially what you try as a policymaker is to tease out as much flexibility as you have in the system, avoiding investments. And in the European context, if you have the assumption that there is demand-side response potential, smart charging of electric vehicles, and so forth, you actually want to avoid giving investment certainty to flexibility assets because you want to tweak out the flexibility that you can get from better operation of existing assets. So, but if we look at whether this strategy can be applied to systems that actually don't have the flexibility available, that don't have the potential in place, actually you need a different approach in those systems that lack the flexibility. And there the long-term contracting is much more significant, much more relevant instrument. And the other thing, the problem of benefit stacking is simply the transaction costs and the institutional challenges where these benefits accrue. And when you have unbundling, it's almost impossible to separate the operation of the assets and allocate the different value streams to whom, depending on how the unbundling works. I think there's a positive message here for systems that don't have unbundling, because if you have a vertically integrated utility, right, what you need to do is similar to the investment plans that you would approve. You need to look at those investment plans considering variable renewable resources and storage, and looking at, is that actually the better package, considering different parameters? It can be costs, there can be other co-benefits that are looked at in the system value, and then give regulatory approval to go ahead and procure the system. So I think in that specific case, and then of course, because it's operated within one entity, you have the same situation like we managed with the smaller customers, that you can really get all the different benefits from one. The problem there is, the innovation that is required in the planning tools and the system operation can be very hard to get from an incumbent utility that generates guaranteed revenues. So they don't really have a big pressure to innovate. So there it's more about how do you actually get them to engage and implement it. And if you get to that point, it can be a very good opportunity actually to do this benefit stacking in practice. It's much easier than in unbundled markets.
Yeah, very much agree. But we need to get there. A long way to go. There's an interesting question that is kind of going to the opposite side of the spectrum, whether we see any trends internationally enforcing deployment of storage with renewables as a must, basically. Anyone has an example? I hope not, but Simon has. Okay.
Yeah, I mean, there's two classical examples. It's the one is not so much on the co-deployment, but it's a storage target that California had. And then Hokkaido, actually in the north of Japan, had it was not an explicit inclusion of storage, but essentially what it did was that it specified an in-feed profile from a wind generator where it was clear that you could only meet this profile if you had storage installed. And I would say, unfortunately, the feed-in tariff was so high that from a developer's perspective, it was actually still profitable to install that storage, balance the individual wind plant by itself, and then feed it into the grid. So I don't think it's very good from a system perspective to try an individual wind or solar plant to emulate a conventional generator by mandating storage. Storage should be seen as one asset class in the system. Variable renewables are one asset class, and you need a system that works together well. That's why we have grids, and that's why we operate them in an integrated fashion.
Yeah, very much agree. And it's precisely 10 o'clock, and we haven't answered many questions, but here we are. I would like to thank my panel today for a very interesting discussion. Let me repeat that the recording and the PowerPoint will be shared by Belen very soon. The actual paper will be published, I think, within the next 2 weeks. It will be available on SMAP's website. SMAP website, the link is at the end of the PowerPoint, so you will figure all of that out. And we will try to answer the remaining questions maybe by email for those that left their emails. Last reminder, there is a webinar from the same series tomorrow morning about reuse and recycling of lithium-ion batteries in developing countries, and then another webinar on Tuesday next week on warranties and what is it? Warranties and safety in individual projects. So please tune into those. Thank you so much, and hopefully we'll see you tomorrow.